Hey guys, how's it going? Long time no see, I guess. It has been a while. That's my bad. Anyway, enough apologies. Let's get into the video. Over the past month, I've been building a clone of the game Hill Climb Racing. It turned out to be a pretty simple game. I actually didn't really have any hassles with it. I mean, it's really just a car driving on a hill. I mean, what could be difficult about that? So yeah, that was a thing. If you somehow missed that, then check out my videos documenting the very scientific approach I used to build the game. Anyway, time to do what you guys are all here for. Time to AI the shit out of it. I'm gonna be using NEAT for this problem. NEAT stands for Neural Evolution of Augmented Topologies. Nailed it. You can click here to check out a video explaining it, which I haven't made yet, but when I do, I'll put it right up there. So if you're from the future, feel free to click that. If not, then I don't know, f***ing Google it. NEAT is basically a super sexy way of combining neural networks with the genetic algorithm. We're gonna be slapping that on some cars so they can learn how to drive. Too easy. But before I do that, I'm gonna add some final touches to give the game a little bit of flair, a little bit of magic, a little bit of Are you ready? Is that what I think it is? No way. No fucking way. Holy shit, Evan, you have outdone yourself this time. It's fucking grass! Yeah, so grass. That probably took me a little longer than I'm willing to admit. Are you impressed enough yet? Can I go home now? Are we done? No? You didn't come here for grass? Fine. Okay, with that done, the only thing left to do is to add a few lines of code, which will add NEAT to the game. Okay, you beauty, she is ready. This is the moment we've all been waiting for, over 2 months in the making. And here we go. So the first oh my no. Oh. No. Yeah, all right. That didn't go so well. There are a few minor things I can probably improve on. All right, here we go. This one should work. And away we go. Really? Silly car. Where are your wheels? You fool. Okay, enough dicking around. I forget sometimes that I'm not like a fail compilation video, like a one-man fail compilation. Oh, that describes me a little too well. Oh, that got a little too real. All right, moving on. After blood, sweat, tears, and fucking grass. Woo! Finally got it working. I'm not pulling your leg this time. I actually got it working. I actually did the thing. All right. Here we go. There are 150 cars in each generation. This program uses the genetic algorithm, which is basically survival of the fittest. If a car does well, then it's selected to be able to breed so that its offspring survives to the next generation, just like normal evolution. At first, the cars have no idea what they're doing. Some are going forward at full speed, some of them chucking it in reverse, but a few of them, not many, just a couple, figure out that they need to go forward without flipping over. Well, they don't quite get it yet, but they're getting there. As the generations go on, the drivers slowly learn how to navigate the landscape. The weird graph thing in the top right corner is the neural network controlling the leading car. That's why it changes when the lead is overtaken. This brain structure is actually what's evolving over the generations. Now let's talk about the inputs to the neural network. This is basically what the car sees. If the neural network is the brain, the inputs are what is perceived from the sensors. You can see these inputs on the left-hand side of the neural network. So the car knows the angle of the car, whether or not it's touching the ground, its angular velocity, how far it is off the ground, and the gradient of the ground in front of it. So basically whether it's going uphill or downhill. The neural network uses these values to figure out what to do next. The outputs are just the controls for the car, so just forward and backwards. change is subtle, but you might notice the terrain is getting more and more difficult the further the cars get. This is because you don't want to chuck the cars in the deep end because they'll learn nothing. Instead, you want to first train the cars on flatter, easier ground so they can figure out how to go forward and not fall over and stuff before chucking them into the really steep and difficult terrain. This is known as incremental learning, at least I think it is, that's what I call it, so deal with it. It's basically the concept of learn to walk before you can run, or don't teach a baby Shakespeare. A cute little touch that I've added, which I doubt anyone actually noticed, is that the drivers' shirts are actually genetic. This means that the color of a player's shirt will be passed down through generations. So at the start, all the players had random colored shirts, but as time goes on, those players who do better have more children, and thus their colored shirt becomes more prominent. This is why all the shirts become green in no time at all. I don't know, I thought it was cool, cute little touch, but if you don't care, then I don't blame you. Wait, I'm pausing it here. Did you see that? I think this is my favorite shot in the entire thing. You have car after car struggling to make it up the hill, giving everything they can to surmount the insurmountable, and then you have one final car remaining. There's no one around, all eyes on him, all hope is in this one car, and as he slowly topples down to his demise, you pan back to his mate just hanging out, giving zero fucks. You want to move, mate. You want to give him a hand. Bloody useless. What? How did you get here? How are you there? Why aren't you driving? What are you doing? Anyway, as you were. So yeah, I'm going to skip to Generation 14 because nothing really happens up until then. The insurmountable hill has finally been conquered, and surely he will continue his triumphant conquest, and he's dead. Generation 16, we finally get even further, and this time for sure he will continue, and he's dead. Alright, so we're on Generation 17, and we should be pretty close to the end of the map by now. There's not much further to go, so hopefully it's only a few more generations, and it's going a little slower, isn't it? Oh no. No, don't you do this. Don't you f***ing do this. Oh. Fuck. Oh. No, I'm done. I'm out. Have a good day. I'm going home. Okay. All right. So clearly something broke. I think I was pushing my computer a little hard. Running a physics engine is actually a pretty computationally heavy task, so potentially running 150 of those was not my greatest move. So what to do? I could always reduce the population size down a bit, but then they won't learn anything. You need almost a critical mass of players before they'll actually start learning. The solution was actually pretty obvious once I thought about it. We need a large population size without having to run a large amount of players at a single time. So what if we split the population up into groups and run each of those groups individually? This is known as batch learning. It obviously takes a lot longer because for each generation, we need to run the simulation multiple times, but I think it's worth it. I also took this opportunity to increase the population size a little bit. Before we had 150 players, so I decided up a little bit to say 750, but then there is only 50 players at any given time, so it should run a lot smoother. Everything else works the same. Once all the groups are finished, the players which did the best are chosen to pass their genes down to the next generation. Standard shit. different map, but we're already almost up to the same point we got to last time. So yeah, it's significant improvement. Having a much larger population size is a huge advantage because this allows the neat algorithm to better emulate evolution in nature. Because in nature, it's rare to have a population size less than a few 100,000, never mind less than 200. And we have done it. By Generation 4, they have reached the end of the map. Holy shit, we did it. God, this has been a long project. Do you remember those graphs in the top right corner which seem to magically control the cars? If you want to learn how these magical neural networks work, so you can build projects like this one, then you should check out Brilliant.org. Pro tip, it's not magic, it's actually math and computer science. Brilliant.org has interactive lessons on neural networks which give you all the tools you need to build your own. Neural networks might seem like a bit of a daunting task, but they break it down into small chunks which are super easy to understand. And unlike me, they actually take the time to go into the details you need to understand it, not just label it as black magic and move on. The first 200 people to use the link brilliant.org/codebullet will get 20% off an annual subscription. So if you want to learn how to summon magic graphs and also support this channel at the same time so I can make more of this content, then I would really appreciate it if you'd go check them out. Woo! Alright, thanks for watching. Thank you for the people who've been with me the entire time. It's been one hell of a ride. I'm pretty keen to move on to the next project because this has been like months at this point. Sorry this did take so long. University's getting hectic and I went to New Zealand for a bit. I just really didn't have enough time to spend on CodeBullet stuff. Speaking of uni, we're getting to the really ugly end of the semester. Sorry to inform you that I'm gonna have to take some time off CodeBullet. I finish on like the 20th of this month, so it's only like a week or two. But yeah, I have to spend some time focusing on uni because that is still important. But after that, we'll be on summer vacation, which means I will have 3 to 4 months of time to spend just doing CodeBullet stuff, which I'm actually really excited about. I've never had a decent amount of time to focus just on CodeBullet stuff. There's always been university or I've been sick or going away. On the like 20th or 21st, I'll probably put out an announcement video, just heads up to see what you guys can expect for the next few months, what my plans are, that kind of thing. Anyway, thank you for watching. Sorry this outro has been a bit long, been rambling a little bit. See you around.